number 65, page 753. This is a good problem, or not, yeah, number 65. Both of these A and B are good problems. They're asking you to find the halfway to the equivalence point for the following titrations. This forces you to really memorize what is the equivalence point and what is halfway to the equivalence point. And actually we're just going to cover 65A, and then I'll make another video with 65B. So, first of all, what is the equivalence point? The equivalence point is when the moles of the base equal the moles of the weak acid. Okay? That is the equivalence point. So, first thing we have to do is figure out how many moles of my weak acid that I have. Okay? Now, if we were doing a strong base with a strong acid, we know the pH is 7, because a strong base and a strong acid will cancel each other out and you'll have a pH of 7. But that's not the case with a weak acid. So the base we have is 0.1 molar sodium hydroxide, and the acid we have is 100 mils, or 0.1 liter of 0.10 molar. Okay? So they're nice in that they're giving us the same concentration. So if it's the same concentration, I don't even have to calculate the number of moles, because I know that in order for them to be equal, I'm going to need 0.1 liters of this. Okay, so I know how much sodium hydroxide I'm going to need. Okay? But just for fun, I'm going to show you that, because in the later part of the problem, we're going to need so I've got 0.0100 moles of my weak acid. In this case, it looks like it's heptanoic acid. Okay? But like I said, we can just skip this step here, because we know, since their concentrations are the same, since this concentration and this concentration are the same, we know that their volumes are going to have to be the same in order for them to cancel out. Okay. So, if we do our before and after table, this is before. Afterwards, okay, but the volume is how much? Because when we put it into the Henderson-Hasselbalch equation, we need molarity, not moles. So when I go back here, remember I've got 0.1 liter of that, 0.1 liter of that. So when we mix them together, I'm going to end up with 0.2 liters. So my molarity is going to be 0.00500 molar of the C7H5O2. In fact, I misspoke. We're not putting this into the Henderson-Hasselbalch equation, because the Henderson-Hasselbalch equation does not work at the equivalence point. Where are we on the titration curve? We are right here, okay? And that's why problem number 55 is so important, because you need to know where you are on the curve. When you're at that point, you do an ICE table that is based only on your weak base. that was created by adding your strong base. Okay? The Henderson-Hasselbalch equation only works in this region. Okay? So we're going to have to do an ice table. And my initial concentration is 0.00500 molar. None of this, none of this. I'm going to lose X, gain X, gain X. So then my KB is going to equal X squared over 0.005 minus X. This X will be too small, but we need to know KB. And we don't know KB, we know KA. So we're going to have to figure out the Ka is given to us as 6.4 times 10 to the negative fifth. So my KB is going to equal 1.56 times 10 to the negative 10. Okay. So I'm going to solve for X, and X will give me the concentration of OH. Okay. And so then to find the POH, and I get this, which means then my pH is 13. Okay, and the equivalence point of a strong base titrated with a weak acid should be above 7, right? It should be, the equivalence point should be basic. All right. Now we have to do halfway to the equivalence point. So halfway, okay, that doesn't mean we take half of the pH. That's wrong. People get confused and say, oh, my pH at the equivalence point is 13, so I just take half of that. No, completely wrong. Halfway means that the number of moles you have up here means that this number of moles is half of this number, okay? So if that number is half as much, and I kind of proved this before, but so I'll do it quicker this time around. So if the moles are half as many, So if before and after this will go away, I'll end up with this much of this, and I'll end up with this much of this, okay? So at halfway to the equivalence point, the moles of your weak acid are equal to the moles of the conjugate base, okay? And it's important to keep those things clear, okay? At halfway to the equivalence point, this number is half of this number, but your moles of weak acid and conjugate base, they are equal at halfway to the equivalence point. Therefore, at halfway, as I mentioned before, the ratio of A minus to is 1. And so the log of 1 is 0. So at halfway to the equivalence point, pH is equal to pKa. So that problem is, that portion is easier, finding halfway to the equivalence point, because all we have to do is take the, all we got to do is find the pKa. The problem tells us that the Ka is 6.4 times 10 to the negative fifth. So the pKa is going to be 4.19, which means the pH is 4.19 at halfway to the equivalence point. All right? I will do 65b. We're doing the exact same thing, but this time with a base.